So now we'll start with membrane technology, right? So membranes are widely used in the purification of water. Okay. So you know that this raw water quality varies from location to location, right? For example, if you take borewell water, what all impurities it will contain? Of course, there may not be any organic impurities, right? In borewell water, you are digging from the earth crust, right? So there will not be any organic impurities, but it contains some dissolved salt, right? So what all dissolved salts it may have? You be interactive. What all dissolved salts it may contain? Calcium, magnesium, and also fluorides may be there. Okay. So if fluorides are there in excess quantity, they are not fit for drinking purpose. Okay. If fluorine is excess, so you have to remove that. So for that you are going to use some membranes. Okay. Then, for example, the water which you are going to use in industry, that may contain a lot of TDS, that is total dissolved salt content will be more. You have to purify that. You have to reduce the total dissolved content. For example, if it is more hardness, if it is more hard water, okay, that you cannot use in sugarcane industries because the sugar will not crystallize out if you use this hard water. Okay, and you cannot use this water which contains high TDS in paper industries. So for that, you have to subject it for some process to remove uh, total dissolved salts. Okay, you have to reduce the dissolved salts. And for example, if you are using in chemical industries like in boiler, so in boiler, if you use this hard water or water which contains heavy TDS, what happens? That salt will salt will
Voice is breaking, sir.
settle on the surface of the boiler, right? So it leads to the corrosion of the boiler. So you have to avoid that. Sometimes it chokes the wall, it chokes the inlet and outlets of this uh, boiler. So in that case, you may expect some explosion. So for that, you have to reduce the total dissolved salt. Okay, and sometimes you will not be getting any water from other sources like borewell, lakes, and all. You have to use this sea water, right? That sea water is also called as brackish water. Okay, so how to convert this sea water into uh, potable water or water which can be used for domestic purposes, right? So you have to go for again.
Desalinations.
You have to use membrane and you have to subject it for desalination. Okay, and municipal wastewater. So this municipal wastewater contains a lot of organic and inorganic impurities along with some pathogenic microbial organisms, right? So that cannot be recycled. So if you use membranes, so all these things are possible. Okay, so for that we are going to use these membranes. Usually the polymeric membranes we are going to use here. Okay. Now, what are the types of membrane filtrations? So based on this filtration type, these membranes are also classified. Okay, so I'll show you one diagram here. So you can see here, see in this first membrane, you can filter only the particles or substances which are having the particle size from 10 to 0.1 micrometer. Okay, so the particles are the impurities which are having the sizes from 10 to 0.1 micrometer. Only those things can be filtered by this using this membrane. Can you see this? And this kind of membranes are called as microfiltration membranes. And this process is called as microfiltration. So in this type of filtration, you can filter only the particles or the impurities which are having sizes in between 10 to 0.1 micrometer, right? So you can filter here some bacteria and suspended particles you can filter by this kind of filtration. And this kind of filtration is called as microfiltration. And the membrane used in this particular filtration is called as microfiltration membrane. Have you understood this microfiltration membrane? You can filter only this kind of the impurities having this size, that is 10 to 0.1 micrometer, right? So all other particles, all other smaller particles will pass through this membrane. Let it be. But this kind of membrane is called as a microfiltration membrane, and this process is called as uh, microfiltration process. Okay. And next type of membrane is called as ultrafiltration membrane. So here you can filter even smaller particles like 0.05 to 0.005 micrometer size particles like colloids and macromolecules, right? So you can filter this kind of particles here. So this kind of filtration is called as ultrafiltration, and the membrane used here is called as ultrafiltration membrane. Okay, this is just for your information. Then next type of filtration membrane is nanofiltration membrane. Here you can filter the particles of sizes 5 into 10 to the power of minus 3 to 5 into 10 to the power of minus 4 micrometer. Okay. So for example, sugars, dyes, divalent salts, all these things you can filter from this uh, nanofiltration membrane. But these cannot be filtered by using other two above two membranes, right? Through above two membranes, these nanoparticles like these particles like sugar, dyes, and divalent salts will pass through. Okay, so it is possible only through by using nanofiltration membrane. Okay, and coming to last type, that is reverse osmosis. Here you can filter the particles of the size 1 into 10 to the power of minus 4 to 1 into 10 to the power of minus 5 micrometer. Right, very small particles you can filter here. Right, so here monovalent salts and ionic metals you can filter, and this kind of membranes are called as reverse osmosis membranes. These are also called as RO membranes. Okay, and these kind of membranes usually they will allow the passage of only water, not any other matter, any other suspended particles, right? So this kind of membranes are called as reverse osmosis membranes. Am I audible? Just
Yes.
respond.
Yes, sir.
Yeah. So have you understood this kind of filtration membranes? First one is microfiltration. You can somewhat bigger particles you can filter here, and in ultra filtration membranes you can filter the particles of size 0.05 to 0.005 micrometer, right? And in nanofiltration membranes you can filter the particles of size 5 into 10 to the power of minus 3 to 5 into 10 to the power of minus 4 micrometer, and through reverse osmosis membrane, you can filter the monovalent salts and ionic metals like which are having the particle size of 1 into 10 to the power of minus 4 to 1 into 10 to the power of minus 5 micrometer. This is called as microfiltration process, ultrafiltration process, nanofiltration process, and lastly reverse osmosis. Here you can remove all these salts, bacteria, monovalent salts, and ionic metals like heavy metals. All these things you can filter by using this reverse osmosis process. And this also another form of other last slide. Okay, same thing. I put it in this form here. Now, what are the advantages of membrane technology? For example, somebody told through coagulation you can filter the water, right? And through distillation you can filter the water. And do you know how you are going to do the distillation? What is the principle behind distillation? Can anybody tell me what is the principle behind distillation?
So boiling point of
Rate
water.
of particle.
Yeah,
Boiling point.
Yeah, boiling point. With boiling point, what we are going to do?
We are going to evaporate the
Yeah, evaporation and condensation, two things, right? So you are evaporating the water and condensing it. Are you following this or not? The principle behind this
Yes, sir.
distillation is
Yes, sir.
evaporation and condensation. Evaporation and condensation, right? So during evaporation, to evaporate water, what you have to supply? You have to supply energy, right? Heat energy, right? So a lot of energy is required for this process. And also during condensation, there is a lot of wastage of water. Yield will be very less, right? So all these are these are disadvantages of distillation. So usually, if you want to filter the water in bulk quantity, that is not the suggested method, distillation. And even in coagulation method, you cannot completely filter, remove all the dissolved salts in this, right? Only suspended particles you can dissolve, separate. Okay, only suspended particles, they will undergo coagulation and they can be separated, but dissolved particles you cannot separate. So all these things are possible through this membrane technology. If you use different membranes like ultrafiltration, microfiltration, and this reverse osmosis membranes, that is possible to remove all the impurities, even dissolved salts, dissolved ions. Sometimes bacteria and uh, virus, it is difficult, but bacteria you can separate. Okay. Now, what are the advantages of this membrane technology? Energy saving, what I told. There will not be any energy you are going to invest here, right? Like distillation. In distillation, you have to supply energy, heat energy. Okay. So energy savings, you can do the saving of energy here, and low temperature operation. You are not going to heat anything here. At room temperature only you can filter. Okay. And recovery of water will be very high. Of course, in your reverse osmosis process, whatever Kent RO you are using, there little bit of loss of water will be there, but compared to other processes, it is less. Recovery is good. And water reuse. Okay, so the rejected water, for example, in your water filtration, you might have seen some rejected water will be there. That water can be reused, right? And compact operation. Operation is very simple. And automatic operation. So nowadays, you are standing in front of your water filter, no, right? You just switch on and you will do other work, right? Automatically, it will start filtration, and when the tank is completely filled, automatically it will get off, right? Then tailored systems. So you can tailor the instruments as per your requirement. Okay, so that is called as tailored systems. So as per the sizes, batch sizes, and as per your requirement, you can design different types of filters and membranes. So these are all the advantages of membrane technology. But there is one disadvantage: high cost. Initial cost will be high. Okay, but compared to other, that this is also advantage only. Compared to other techniques, it works cheap, but these are the advantages.
Excuse me, sir.
Have you studied or what?
Yes, sir.
Sir, in this membrane technology, even the water purifier in our house, but in that water purification, but almost like 60% of water is lost, no, sir? I mean, only 40% is purified and given to us. We have a wastage of 60%.
See, you cannot say it as a loss. You can reuse that one, no? Are you using?
Sir,
Are you doing that?
Sir, but that is only for domestic purpose. When you talk about a
Next
water
advantage I told, you can reuse that.
Sir, but if we talk about filtration purpose
Pardon?
but if you talk about filtration purpose for human consumption, you're still having a loss of 60%, no, sir? Because that's what a water purifier is supposed to do. it's membrane technology itself.
No,
right?
actually you can reuse that rejected water. No, you are reusing that rejected water.
Sir, but
You can use it for gardening purposes.
sir, but I'm not able to consume it.
But in
sir.
other processes like distillation and all, you cannot reuse that one. It will escape.
Sir, but while writing the
Okay.
disadvantages, we can write this point, no, sir. Because the main point of having
Which
a
one?
water, for writing the disadvantages of membrane technology, we can write this point, sir, that 60% of water is like it can't be used for
Do you have
human
any
consumption.
data exactly 60% of water is rejected like that?
Yes, sir.
It depends on the membrane. It depends on the process, which process you are going to use.
I'm talking about
There are different types of membrane filtrations, membrane technologies.
I'm
All
talking
will not be
about
having
osmosis.
60%.
No, the one we
Only
use
your
at home.
water filtration, which are using in your home, that may be having 60%.
Yes, sir. It averages between 50 to 60%. So
But you can reuse that one, even though the rejected water percentage is 62%, 50 to 60%. It works cheap compared to other processes. Okay, that is why
Okay, sir.
this process is universally accepted. Okay, even seawater also purified by using this membranes. Using membrane technology only, they are doing that.
Okay, sir.
Right?
Okay, sir.
Yeah,
But
you
can
can
we
write
write
it
it
as a
as a
disadvantage.
disadvantage point?
Yeah, you can write. You can write. You can write.
Okay, sir. Thank you,
Okay.
sir.
Then what about osmosis? What do you mean by osmosis? I think you studied this osmosis, right?
Yes, it's diffusion of particles from
Through
higher
a semi-permeable
concentration
membrane.
to lower
Diffusion of
concentration.
particles. Diffusion of particles. Suppose I'll give you an example. I take this sea water and pure distilled water. Okay, and I'll separate this distilled water and sea water by one membrane called as parchment membrane. Okay, so how will be the movement of water molecules?
From seawater to distilled water.
Yeah, any other answer?
From distilled water to seawater.
Yeah. Which one is correct? Only two possibilities. Okay. From seawater to distilled water or distilled water to seawater. Which one is correct?
Seawater to distilled water.
Seawater to distilled.
Seawater to distilled water. Can you tell me why it moves from seawater to distilled water?
That they attain similar
Higher
concentration.
Higher concentration.
No, so they attain similar concentration.
So to attain similar concentration, it moves. Any other answers?
It moves like particles move from an area of higher concentration to an area of lower concentration. So in seawater,
I'm not talking about I'm not talking about particles. I'm asking about water.
so water will
So
move from distilled to sea.
distilled to seawater. Yeah, that is the correct answer, right? Why? Can you tell me?
So because concentration of pure water
Why?
is more, and distilled water has more content of
Again,
pure water per.
concentration is more. Solvent should be the solution. So so in reverse, natural osmosis.
Your voice is breaking a lot.
Sir,
Sir, your voice is
Can't hear you,
breaking,
sir.
then your voice is
So
like
your
2x
voice is
Is breaking.
speed,
Can't
sir.
clearly hear you.
1 minute.
Sir, if you turn off your video, sir, then your voice will not break, sir, actually.
Yeah, better. I'll do that. I'll do that. Can you see this PPT
Yes, sir. Yes, sir. Yes,
now? His voice is clear?
yes sir.
Okay.
Yes, sir.
Yeah. Yes, thank you. So we studied the advantages of this membrane, and we are talking about the osmosis process. Okay. So in this osmosis, now voice is clear, I guess.
Yes, sir. Yes, sir.
In this osmosis process, when concentrated solution is separated by less concentrated solution like seawater and pure water by some membrane like parchment membrane, okay, so there will be a movement of water molecules from fresh water to seawater, right? And this process is called as osmosis process. I think you can see this board.
Yes, sir.
Okay, so suppose this is the membrane, and I'll call this as semi-permeable membrane. Semi-permeable membrane. And this semi-permeable membrane allows only the passage of solvent molecules. Solvent molecules. It allows the passage of solvent molecules. And here what I am doing, I am taking highly concentrated solution. For example, seawater. And in this compartment, I am taking distilled water. When the seawater and distilled water are separated by a semi-permeable membrane, there will be a movement of water molecules from the distilled water to seawater. And this process is called as osmosis. This process is called as osmosis. This is very important, you should remember. Okay, when the high concentrated solution and low concentrated solutions are separated by a semi-permeable membrane, there will be a movement of solvent molecules from low concentrated solution to high concentrated solution. And this process is called as osmosis. And during this process, there will be some pressure exerted on this membrane. Some pressure is exerted on this membrane and it is represented by phi. Okay, and this pressure is called as osmotic pressure. This pressure is called as osmotic pressure. Then how will you define osmotic pressure? It is a pressure exerted by the semi-permeable membrane during osmosis process is called as osmotic pressure, and it is called as it is represented by pi. Okay, and in another process, if you apply some pressure here, if you apply some pressure on this higher concentration side, okay, if you apply pressure here, that pressure should be more than this osmotic pressure pi. if you apply the pressure, osmotic pressure on it, then
Sir, your
what
voice
happens?
is like
What happens to the
2x
flow of
speed,
water
sir.
molecules?
Very fast, very fast. Hello, sir.
The higher concentration side, then what happens? The water molecules.
Hello, sir. We can't hear you.
Sir, you're not audible, sir.
Sir, we can't hear you. You're not audible.
Am I audible now?
Yes, sir.
Okay. So think that this seawater and distilled water, they are separated by semi-permeable membrane. Okay. So there will be a movement of water molecule from distilled water side to seawater, and this process is called as osmosis, right? And the pressure exerted on this polymeric membrane, that is semi-permeable membrane, right, during the osmosis process is called as osmotic pressure. Okay, and if you apply the pressure more than this osmotic pressure on higher concentration side, okay, so then there will be a movement of water molecules from seawater to distilled water. Are you following this? Yeah, my voice is
Yes,
clear
sir.
or not now?
Yes, sir. Yes, sir. It's clear, sir.
Yeah, there will
Clear,
be a
sir.
reversal of this natural osmotic pressure, right? So we reversed the natural osmotic pressure by osmotic process by applying the pressure on higher concentration side. Okay, and this process is called as reverse osmosis. Very simple. And this process is called as reverse osmosis. Have you understood the reverse osmosis now? It's very simple. So to understand the reverse osmosis process, you should know what is osmosis first, and then you should know what is osmotic pressure. And if you apply the pressure on higher concentration side, more than this osmotic pressure, so there will be a reversal of movement of water molecules from higher concentration side to lower concentration side, and this process is called as reverse osmosis. Have you understood this?
Yes, sir.
Okay. So once you know the reverse osmosis principle behind this reverse osmosis, and this principle is used for the purification of water. Okay. See that in this reverse osmosis, this semi-permeable membrane, this this membrane is called as the RO membrane. Okay. The semi-permeable this osmosis process, this membrane what we are going to use, that is called as RO membrane. So all these things you can filter. Okay. That is sugar, sorry, salt, sugar, molecules, particulates, and suspended matters. Everything you can filter through this membrane, and this membrane we are using in osmosis. Okay, osmosis is the movement of water across semi-permeable membrane, that too from lower concentration side to higher concentration side. Okay. Now, osmosis is the movement of water. So in this figure, it is red dots. Okay. So this red dot is water, and blue dot is solutes or salts dissolved in the water. You can consider, right? Here the concentration is very less. This side, I think you are following this figure. Are you following this figure?
Yes, sir.
Yes,
Yeah.
sir.
Yes, sir.
Here,
Yes, sir. Yes, sir.
here low solute concentration and here high solute concentration. These blue dots are solutes, and this red dot is water, that is solvent. Okay, and these two different concentrated solutions are separated by a semi-permeable membrane. This is a semi-permeable membrane. So there will be naturally there will be a movement of this water molecules from this lower concentration side to higher concentration side, and this process is called as semi-permeable membrane. Okay, have you understood this or not?
Understood, sir.
Okay,
Understood, sir.
yeah. In this reverse osmosis, the movement of solute molecules through semi-permeable membrane from higher concentration to lower concentration, or the process which reverses the natural spontaneous osmosis process, is called as reverse osmosis. Okay, so spontaneous osmosis is what? There will be a movement of water molecules from lower concentration to higher concentration, right? But in movement of water molecules from higher concentration to lower concentration. Okay, how it is achieved? By just applying the pressure on higher concentration side. So that is called as reverse osmosis. So this is the figure to explain this osmosis and reverse osmosis. See here, this is the membrane. Okay, consider this as a membrane, and this is pure solvent, and this is solution. So solution means here the concentration is more. Okay, so in this condition, what happens? The solvent passes the membrane to the solution side from here to here. The arrow mark is shown here, from low solute concentration to high solute concentration. Okay. Then in reverse osmosis, what happens? If you apply this pressure more than osmotic pressure, okay, more than osmotic pressure, what happens? There will be a reverse movement of water molecules from higher concentration side to lower concentration side, and this process is called as reverse osmosis. It is very simple. See here, in this reverse osmosis, this is the solution side, and this is the pure solvent. We are applying pressure here, and there will be a movement of water molecules from higher concentration to lower concentration. In this animation, you can see here. Okay. So now we are using this reverse osmosis process for desalination of water. What do you mean by desalination? Very simple. Come on.
Removal of salts from water.
Removal of salt from water. Okay, that is called desalination.
The removal of salt
Yeah.
from water.
So usually for desalination of water, we are using this reverse osmosis process, but because it works out economically. So this is the diagram for osmosis. It is okay. So now you are applying the pressure. We are applying the pressure here. Now the solvent molecules, that is water molecules, moving from higher concentration to lower concentration side, and the volume is increasing here, right? So this is osmosis. Okay, it is osmosis. So during osmosis, what is happening? Just see this animation. This is the membrane we are using. This is pure solvent. This is salt molecule. This is the solution. Salt is dissolved in this, and this process is called as osmosis. There is a movement of water molecules from lower concentration side to higher concentration side. Now what we are doing? We are applying pressure here. See here. In reverse osmosis, we are applying pressure. If you apply pressure, what happens? The water molecules will move from higher concentration side to lower concentration side, and this process is called as reverse osmosis. Okay, very simple principle. So this is RO membrane. This is one setup. This is RO membrane, and we are passing here. We are taking this salt water and applying the pressure. Okay. So there will be a reverse osmosis happening here, and you are going to get pure water here. This is one kind of RO filtration setup. There are different arrangements will be there. So this is one more. This is the concentrated water and this is pure water. Here we are using semi-permeable membrane and applying the pressure on concentrated water, right? So if you are not applying the water on applying the pressure here, what happens? If you are not applying pressure, what happens here?
Osmosis takes place.
Osmosis takes place. There will be a movement of water molecules from this pure water side to concentrated water side, right? So we have to reverse this natural osmosis or spontaneous osmosis. So for that, what you have to do, we have to apply the pressure on the concentrated side. Okay. So if you apply the pressure, there will be a reversal of natural spontaneous osmosis process, that is the water molecules moving from the higher concentration side to lower concentration side, and you are going to get a pure water here. See, this is one example it is shown here. This is the ocean water. Okay, so ocean water, and it is subjected to pre-treatment. Why you have to subject it to pre-treatment? Come on. Pre-treatment means what?
Bacteria.
See, ocean water contains what all things?
Bacteria.
There will be many impurities which are bigger in size, right? So you can separate them by simple filtration. So that is called as pre-treatment. Okay. So after the pre-treatment, you have to subject it for reverse osmosis. Okay. You subject it for reverse osmosis, right? Once you subject it for reverse osmosis, you are going to get fresh water here. And during reverse osmosis, there will be some rejected water. Okay. That rejected water and which contains debris and all, that can be reused again here. So you mix it with this and subject it to pre-treatment, and again it is subjected to reverse osmosis to get fresh water. Okay, so this is the general process involved in reverse osmosis process. But in water filtration, what you are going to use in your kitchen, right? So it is again, they will mention on that RO coupled with UV. So RO means what? It is reverse osmosis, and UV means ultraviolet radiation. What is the property of ultraviolet radiation? Why you have to use that one? It is used as a disinfectant, right? If any unfiltered pathogenic organisms are there, right? So those will be killed by using this UV, right? So if you pass UV light to that, what happens? Those pathogenic organisms will be killed, right? Which are not filtered or which are not separated in reverse osmosis process. So that is why RO is coupled with, after RO reverse osmosis, that will be irradiated to UV light. Okay, so that is called as RO coupled with UV. So whatever water filters you are going to use in your kitchen, they will be having this setup. They will mention on that. Just go and check RO coupled with UV, or sometimes ozone. Okay. So this is about reverse osmosis process. I think you might have understood this one. Have you understood reverse osmosis?
Yes, understood, sir.
Okay.
Yes.
Now,
Sir, understood.
okay. The reverse osmosis membrane, the membranes used here are usually commonly used are this polysulfone membrane. It is called as polysulfone membrane, right? So this polysulfone synthesis and all you are going to study in this polymer chapter, last chapter. But time being, you just remember the structure of this one, right? So this contains polysulfone membrane. Usually commonly used membrane in the reverse osmosis process is this polysulfone membrane. Why you are going to use this polysulfone membrane only? What are the advantages of using this polysulfone membrane? That we'll consider now. So it contains a hydrophilic group. So hydrophilic means what? Hydrophilic means what?
Loving.
Water loving, water attracting. Okay, so water attracting group, and also it contains hydrophobic group. Okay, so the sulfone group is water loving group, water attracting group, because it contains polar oxygen atoms like this, right? So it attracts the water. And hydrophobic group means this is water hating group, so this rejects the water. Okay, so your membrane should, polymeric membrane should balance these things. It should be hydrophilic as well as hydrophobic. If it is only hydrophilic, what happens? The water molecules will come and settle on the membrane. Okay, are you following this or not? If it is only hydrophilic, and if it is only hydrophobic, there will not be any filtration. Water always it will go away from the membrane. So it should be balanced, right? This hydrophilic and hydrophobic property should be balanced in the membrane. So this membrane is having hydrophilic as well as hydrophobic part. This hydrophilic part is sulfone group, and hydrophobic part is this methyl group as well as benzene. These hydrocarbons are always hydrophobic in nature. So this benzene ring or aromatic ring, these are hydrophobic in nature, and also these methyl groups. Okay, so it is having those property, balanced hydrophobic and hydrophilic nature. Okay, so these methyl groups also act as brushes, so they are always vibrating like this. Okay, they are not stationary in the polymeric chain, they are vibrating. They act as brushes and avoids the deposition of salts and hence the flowing of the fouling of the membrane. So what do you mean by membrane fouling? Have you heard this word, membrane fouling? Membrane fouling means membrane clogging. The water, the salt particles and all, they will go and sit on the surface of the polymeric membrane. So further filtration process will not happen. Okay. So the role of these methyl groups is they will give some brushing action on the polymeric membrane, because they are rotating. No, they are not in stationary state. They are rotating always. So they will remove the salts which are present on the polymeric membrane. They will act as a brush. They will give brushing action on the polymeric membrane, right? So therefore this fouling of membrane will be reduced. The water filtration will be fast. Are you following this or not?
Sir, following.
Yes,
Following,
sir.
sir.
Yeah. So the role of methyl groups are, they will act, they will give a brushing action, right? That means they will remove the salts which are salt or any other particles which are depositing on the polymeric membrane. Okay. So all these are advantages of polysulfone membrane, which is used in this desalination of water. Okay. So I'll show you one animation here. So if this is a polymeric membrane, there are methyl groups will be there here. You cannot see that one. If any membrane fouling is there due to the deposition of salts or any other suspended matter, so that can be removed. Fouling will be removed. Okay. So the role of this methyl group is that one, brushing action. Okay. So you may be asked in the exam, what are the advantages of using a polysulfone membrane in desalination of water? Then you have to write this. It is having balanced hydrophilic and hydrophobic properties, because the sulfone groups will act as hydrophilic groups, and this methyl and aromatic groups are hydrophobic groups. And also methyl groups will avoid the fouling of the membrane by giving brushing action on the polymeric surface. Therefore, this is more advantageous to use polysulfone membrane in reverse osmosis. So, hope it is clear to you.
Yes, sir.
Yes, sir.
Okay.
Yes, sir.
Okay. So this is the polysulfone membrane, and feed water is passed like this, passed through, and it will filter. So I'll explain this later. Okay. And these are the polysulfone membranes. So if you go to the microscopic pictures, you can see like this. There will be a pores, right? So pores to pass through the water, and also there will be methyl groups. You cannot see methyl groups in this microscopic images. It is not possible there, right? So you can see this transverse and cross-sectional images of polysulfone membrane. Now, what are the advantages of reverse osmosis? So removes removes nearly all contaminant ions and most dissolved non-ions. That means it removes almost all dissolved contaminants, okay, including ions and non-ions. And RO operates immediately without any minimum break-in time. So if you switch on your this water filter, it starts automatically, right? There is no, it won't take much time. Okay, so that is advantage. It is very quick, you can say, in other words. And operational simplicity and automation allow for less operator attention and make ROs suitable for small system applications. Okay, so just to take the example of the water filter, what you are going to use in your kitchen, you will just switch on that, right? So except this switching on, any operation is required, man operation is required there, no, right? So operational simplicity is very much important here. And what are the disadvantages of this reverse osmosis? So high capital and operating costs. So initial cost will be very high. If you want to buy one small RO system, so it costs from 10,000 to 20,000 initially, right? Which everyone cannot afford. And managing the wastewater, that is brine solution. Salt water will be filtered, no, that is rejected. So that is a potential problem. So you have to use it for, you have to use it properly. You have to reuse it properly. Okay. Am I audible?
Yes, sir, audible.
Okay.
Yes.
Then membranes are prone for fouling. So if it is if the water is having too much TDS, right? So the fouling of membrane is very high. Fouling means what? Clogging. Okay. And these dissolved salts and all, they will go and sit on the surface of the membrane and reduces the further filtration. Okay. So that is one more disadvantage. And colloidal silica is not removed by this process. This colloidal silica is very small, is having very small particle size. So that cannot be removed by this desalination process. Okay, this preparation of membrane, I will consider it in next class. Okay, if I start it, I cannot finish it. Preparation of membrane, I will consider it in next class. If you are having any doubts, you can ask now.
Sir, can you repeat why polysulfone membrane is used, sir?
Pardon?
So can you repeat why polysulfone membrane is used?
Correct. See here, this is the polysulfone membrane. The main advantage of this membrane is, so it will be having hydrophilic groups. Hydrophilic means what? Water attracting groups. Okay. And it will be having some hydrophobic groups also. These hydrocarbons, for example, this benzene ring, that is aromatic ring, and also this methyl group. It is called as gem dimethyl group. Two methyl groups are there on same carbon atom, right? So it is called as gem dimethyl group. So all these are there present in the same molecule. So it balances the hydrophobic as well as hydrophobic properties. This is most required property for the membrane which can be used in water filtration. If it is too much hydrophilic, what happens, right? So it attracts more water. Water may settle on the surface. The further process, filtration process will be disturbed. And if it is hydrophobic, means it always hates the water. It rejects the water. It won't attract the water. Okay. So you have to balance these both. So those properties are there in this polysulfone membrane because of the presence of these groups. Have you understood first point?
Yes, sir.
Okay. So hydrophilic group is sulfone group. This may be asked in your quiz. Okay. So mention the hydrophilic group present in sulfone. Hydrophilic means sulfone group, that is SO2 group. Hydrophobic groups are two groups are there. One is aromatic ring and other one is methyl groups. Okay. And also this methyl, the advantage of having this methyl group is they will create some brushing action on the polymeric membrane, right? The advantage of having this brushing action is it will avoid the folding of the membrane, right? Folding of the membrane means the impurities can come and sit on the surface of the membrane. So if that happens, what happens? There will be decrease in the filtration process, right? There will be what we can call
The membrane will be less effective.
filtration process will be decreased, okay, or sometimes it will be stopped. When all the whole surface of the membrane is deposited by other impurities, right? So filtration process will stop. So to remove all the impurities which are depositing on the polysulfone membrane, some brushing action is required. That is given by this methyl groups, right? So these methyl groups will not be stationary like this. They will be always rotating. Okay, that rotation causes the brushing action on the polymeric membrane, which avoids the falling of the membrane, which enhances the filtration process. Okay, so these are the advantages of using polysulfone membrane.
Sir, this
Right.
brushing effect you told about, sir.
Ah.
Even though the brushing effect is there, let's say that the water is very hard, lot of salts, the TDS is very high, so
Hmm.
it still corrodes the membrane. So then
Correct.
to fix it, sir, like you have to replace the entire membrane, or can you is there a process where you can clean it and you reuse the membrane?
Oh, you have to replace the membrane only. Up
Okay.
to it will be having some life cycle, right? So many some minimum number of cycles, filtration cycles will be there. After that, you have to remove it. You have to change the membrane.
Okay, so it can't be reused. It's a use and
No.
throw thing.
No, it is use and throw.
Okay, sir. Thank you.
Yeah. Anything else?
Sir, will you share this PDF with us, sir?
Which one? This PDF, PPT.
Yes, yeah, PPT, sorry.
So PPT I'll share, no problem. Already I shared the notes, right? In notes, all these things are there.
Yes.
First, you read the notes. So after completion of whole unit, I'll share the PPT. Okay, so that you can use those animations and all. You can understand better, right? I'll do that.
Okay,
Thank you,
thank you,
Yeah.
sir.
Anything else you want to know? So if you don't have any doubts, shall we stop it now?
Yes, sir.
Yes, sir.
Yeah. Yes. Thank you. Thank you, one and all.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Yes, sir.
Thank you, sir.
Thank you, sir.